to ciLiving. Richland Community College is giving students the tools they need to enter the workforce. The Engineering and Technology Department offers hands-on learning for STEM students, leading to jobs in manufacturing and trades, as well as many, many more things. Joining me now with a demonstration on some of what he teaches is instructor Brad Curry. Thank you so much for being here.
Thank you for having me.
All right, so tell me a little bit about the department.
Well, the department is a hands-on department. We teach a variety of different courses that are geared towards preparing students to be machinists, to be electricians, to be electronics technicians, to be maintenance workers, on the repair side, to be CAD draftspeople as well. So, I mean, there's so many different areas that students can go through and go into with a degree, an associate's degree in engineering technology from our program. So I brought a few things here today just to kind of demonstrate. So we're calling it a fidget toy.
Okay, great.
But I'll go into what it actually is once we're done. So as we kind of look at this, so our students would basically, in our engineering graphics class, kind of work on the design and come up with the design for something like this.
So something like this, which is what we're going to make today.
So that's what we're going to assemble today.
Okay.
So, all right. Now our machining students would then kind of machine these parts, and this kind of shows a progression of the machining, so in the different steps that we would be going. So that's a first machining on the turning center, then of course we would drill the holes on our mill, and lastly come in from and actually machine that. So this kind of,
have these little
and then
gears
those are the
as
gears.
well.
So, and those are just stock gears. This, of course, is the fixture that students would have to kind of design and figure out how to make this so that they can hold the part when they go to machine it and make that. So, from that point, of course, maintenance people are constantly tearing things apart and putting things back together, making repairs on this. So, so this gives them some basics as far as learning. A little bit later on, we'll talk about some of the differences in holes, but these are all pretty much prepared. So, so are you ready to go ahead and assemble one?
I'm ready. So we're going to make one right here on ciLiving. So what do I start with?
So you're going to start with the base.
All right. So the base is the one with the 4 holes in it.
Yep.
Okay.
So, and you're going to, and it's a little thicker than our cover plate. So you're also going to need to pull out 4 screws. So you need 4 screws there. So you're going to need 4 gears. 4 gears. Excellent. Got it. And of course you need the cover. As well. Now, of course, all of this would be instructed in the drawings, and of course, on what we would refer to as a bill of material would kind of break this down so that you would know everything that you need to know in order to assemble it. So we'll move these out of the way, get some of your tools. The only thing you really need for this one is a Phillips head screwdriver there. So
I dropped one of my screws. I'll just grab another one.
All right. And while you're doing that one, I'll go ahead and take this one to kind of show you. So
I'll follow along.
So we're going to start with the one in the center. So basically take your screw here and put it through.
A gear in.
Yep.
All right, got it.
So you got that like that.
So that's got to go through both. Okay.
Now we're going to start that one right there in the middle. All right, so I'm going to kind of just use my fingers and do that. So just kind of get that started and keep it fairly loose.
Okay.
All right.
Got
now,
it. So like finger tighten?
Yep, finger tighten is good. Okay. So you're going to take the next one, go ahead and get you another screw. So you're putting that in, and of course you got to kind of line it up. Once you line that first hole up, so now I would also, with my students, we got a 3-hole pattern on this and what we refer to as a bolt circle. Okay. So now, if you talk about the bolt circle, we would mention the mathematics involved with that 3 holes on a bolt circle, basically each of those holes is 120 degrees apart. Okay. All right. Now, with this particular, we could also make and put 5 of these on, so depending on the fidget. So we could do some different designs on that. All right. So, all right, once you get all of yours in there and kind of get them started, you can go ahead and take the screwdriver there and just kind of snug those up.
Finish it up, okay.
Yeah. Now there's a problem with this one. I kind of worked on this, and of course, you know, engineering technology, with all of our students, problem solving is a big skill for them, right?
Of course.
So there's some problems with these. with the way it was designed.
Okay, what are the problems?
As the instructor, I kind of did that on purpose.
Of course.
So if you are going ahead and fidgeting it.
Oh, and I did mine too tight.
Yeah, you did yours too tight, right? So
see, I'm already learning a lesson.
Here, I'll switch with you.
Okay.
So, all right. So now, not only is it possible that you would make this too tight, but you could also keep it too loose.
Oh,
right?
sure.
So, and we would call those different tolerances in engineering. So now, and we would have to figure out ways to kind of keep that from happening. The problem with it being too loose is the screws could work their way out.
Right.
So, and then the whole thing falls apart. So too tight, of course, you see that it doesn't really work. So the students would then have to kind of figure out, okay, well, what can we do to kind of make
How can we adjust it and fix it?
And there's another problem that was kind of related to the machining of it, especially on the cover. Now, you'll notice, take a look here at the design up top, at how that's nice and symmetrical, and how this curve and radius here blends perfectly into the curve and radius around here. Down at these other two, not so good.
Right, I see, yep.
Now, as the designer, so I'd be saying, you know what? So that's not mine, I designed it right. So, well, machinist might be saying, well, so I programmed it, or the programmer, I programmed it, it looked right on my software, and the machinist is like, I don't know, it's not coming out right. So you got to figure out what's going on. Now, in reality, the problem here was with my design.
I see.
So there wasn't, tangent points weren't correct. So when the CAM system spit out the program for the CNC machine to run, basically it overcut and didn't cut right.
I see.
And so then we go back to the drawing board and fix that and make the correction to those errors.
And make it perfect.
And make it perfect.
And so then you said you were going to tell us what this is actually for instead of just a fidget toy. We have about 30 seconds left.
Remember, we're an engineering technology program, so this is actually a planetary gear set, which is a main type of gearing mechanism that's used commonly throughout a lot of industrial equipment and machinery. So you'll see planetary gears used for gear transmission, for torque, for improving efficiencies. So there's a lot of different things. So this is really actually a planetary gear.
Planetary gear. Well, thank you for teaching us how to make that, and hang out because there is still so much more to learn from Brad Curry. We're going to see what else he can show us when ciLiving returns, so don't go anywhere.